Out of the thousands of asteroids that pass by Earth, none have raised more alarms than Apis, the so-called god of chaos. As the largest asteroid set to approach our planet in years, its path has been a major topic of discussion. While scientists, including Neil deGrasse Tyson, initially downplayed the risk of a collision, recent findings have cast doubt on their earlier certainty. A new study suggests that even a small nudge from another object in space could alter Apis's trajectory, potentially sending it on a dangerous path toward Earth. These updated findings have sparked fresh debates about Apis's future and the potential threat it poses. Even NASA is stepping up its efforts, running simulations to test our readiness for such an asteroid impact. So, could this god of chaos asteroid actually hit Earth? Let's dive into the science behind the possibility. Just last month, a small asteroid, roughly 1.5 meters across, named 2024 RW1, entered Earth's atmosphere near the Philippines. While it disintegrated harmlessly upon entry, creating a bright fireball visible to many, the incident highlighted a pressing issue. Current technology can struggle to detect smaller near-Earth objects in time to take action. This concern takes on even more significance when we look toward April 13, 2029. Apis, a much larger asteroid, is projected to pass close to Earth. Spanning 370 meters across, about the size of 3 football fields, Apis has been monitored for years. However, new data has raised concerns about its potential for collision with Earth. To understand why, let's first look at the history of this asteroid. Discovered in 2004, Apis is part of the Aten group, a class of asteroids that often pass near Earth. Its size alone, 370 meters, has made it a subject of intense scrutiny. Early predictions indicated a 2.7% chance of a collision with Earth in 2029. Such an impact would release the equivalent of 65,000 atomic bombs, wreaking havoc on life and infrastructure. Thanks to advancements in tracking technology, our understanding of Apis's path has improved over time. By 2013, NASA reassured the public that the asteroid would safely pass Earth in both 2029 and 2036, at a distance of around 31,000 kilometers, closer than some of our satellites. This close approach presents an exciting opportunity for scientific study, allowing researchers to gather valuable data that will help refine asteroid impact models. But why does Apis matter so much? The attention it's receiving from the scientific community is largely due to its upcoming close encounter with Earth in 2029. You might wonder what the big deal is about a close flyby. To put it into perspective, let's look back at an event from 1994, when comet Shoemaker-Levy 9 collided with Jupiter. This was the first time scientists directly observed a celestial body crashing into a planet. The resulting impacts left visible scars on Jupiter's surface, demonstrating the immense destructive power of such collisions. Before the Shoemaker-Levy 9 event, many thought asteroid and comet impacts were exceedingly rare, occurring only once every few million years. But witnessing the impacts on Jupiter shifted this perspective dramatically. It made clear that these kinds of events are not as unusual as once thought, prompting major funding boosts for asteroid monitoring programs. NASA and other space agencies have since ramped up their efforts to track near-Earth objects and identify potential threats. The Kitt Peak National Observatory, KPNO, in Arizona has played a key role in this effort. Located at 2,896 meters above sea level, KPNO has contributed significantly to the discovery of many important celestial objects, including Apis. Since its discovery, Apis has been closely monitored due to early predictions of a possible collision with Earth in 2029. Measuring around 340 meters in diameter, it was initially classified as a highly dangerous asteroid, earning a Level 4 rating on the Torino Impact Hazard Scale, the highest rating given to any asteroid by NASA at the time. The close approach of Apis on April 13, 2029, will remain a key event. Passing within 32,000 kilometers of Earth, closer than some geostationary satellites, it will be visible from parts of Europe, Africa, and Asia. This rare opportunity to observe such a large asteroid up close will allow scientists to study its behavior in detail and refine their models of how asteroids interact with Earth's gravity. But does this mean Apis is likely to hit Earth? A recent study by Canadian astronomer Paul Weir challenges earlier predictions, suggesting that Apis's trajectory may be more uncertain than previously thought. Wirt's research proposes that even a slight impact with another object in space could alter Apis's path, increasing the possibility of a future collision with Earth. This revised analysis has sent shockwaves through the scientific community. Wirt's study shows that, while Apis's orbit is currently deemed safe, a small impact with another space object, like an asteroid or debris, could push Apis into a keyhole trajectory. This is a specific path influenced by Earth's gravity, which could potentially result in a future collision. Although the likelihood of this happening is extremely low, less than 1 in 2 billion for 2029, the study emphasizes the unpredictability of space and the potential consequences of even minor collisions. Researchers now stress the importance of continuous monitoring of both large near-Earth objects like Apis and smaller debris that could indirectly pose a risk. So how is NASA preparing for this and other potential asteroid impacts? NASA is already taking steps to defend against asteroid threats. Recently, nearly 100 experts from U.S. government agencies and international partners gathered at the Johns Hopkins Applied Physics Laboratory for a planetary defense simulation. This tabletop exercise, led by NASA's Planetary Defense Coordination Office, simulated the challenges of a potential asteroid strike. The exercise involved a scenario where a hidden asteroid, invisible to Earth-based telescopes for months, was on course to hit Earth. The scenario highlighted the importance of early detection and the challenges of tracking objects that are hidden behind the sun or are otherwise difficult to spot. NASA and other space agencies are continually working to improve their ability to identify and track near-Earth objects, even those that remain undetected for extended periods. For example, NASA's Double Asteroid Redirection Test, DART, recently demonstrated how to proactively redirect an asteroid by colliding with it, a critical milestone for planetary defense. These efforts are vital for understanding how to prevent future asteroid impacts and mitigate potential damage. Since May 2021, tracking Apis has been difficult due to its position relative to the Sun. According to Weir, Apis will remain out of view until 2027, as it is currently too close to the Sun's glare for ground-based telescopes to observe it. Once Apis becomes visible again, astronomers will have a narrow window to monitor its path and update predictions before the close approach in 2029.